Hello, everyone. I'm making some videos for you to help with the Module 1 prerequisite assignment. This one is going to be about graphing parabolas. So a parabola is the mathy term for the graph of a quadratic equation. A quadratic equation is one that looks like this. Um, the general form of a quadratic equation looks like y equals ax squared plus bx plus c. So this is our general format of a quadratic. Um, so basically, the way that we're going to kind of go about this is a quadratic function is a parabola. A parabola is a U-shaped graph. It's either going to look like this or it's going to look like this, right? It's either a I guess a regular shaped U or it's an upside down U. um, it's going to open up and be a smiley face like this if your a value, the number in front of your x squared, is positive. If your a value is greater than 0, you're going to be positive and happy, and it's going to look like a smile. If your a value is negative, if the number in front of your x squared is negative, if you're feeling negative, you're going to be sad and frowny, and it's going to open downy. It's kind of a bunch some mnemonic aids there to help you remember that. Um, and then another thing that quadratic functions have is something called an axis of symmetry. These guys are always a perfect U shape, which means that there's a vertical line here where if you kind of folded this in half, this side and this side would be on top of each other if you folded it, right? It's symmetric about that line. This one also, even if it opens down, again, this guy's symmetric. If you folded it along that vertical line, um, it would be the same on the left and the right. They would be on top of each other when you folded it over. So that's called an axis of symmetry. And the point where the axis of symmetry um, hits your function, that point where they intersect, this point right here, if you open up, and this point here, if you open down, that's where you have a maximum or a minimum on your function. We call that a vertex. Whether you open up or down, that point is called your vertex. Now, how do you find that point on the quadratic? That's an important thing to remember. So if you have the equation ax squared plus bx plus c, the location of your vertex is going to be the ordered pair where your x coordinate is equal to whatever minus b divided by 2a is. And this b value is the b that comes from ax squared plus bx plus c, and this a value here on the bottom is this a in front of your x squared. So when you do minus b divided by 2a, sorry, I went over that too many times and it's hard to read. Let me try to make that better. Once you do minus b over 2a and you get a number, that is the x coordinate of your vertex. And then to get the y coordinate of your vertex, well, if you have an x value, how do you find y? Well, you would plug it in. So it's going to be whatever you get when you take that and plug it in. Usually we write f of minus b over 2a. You're just going to take whatever number you get here and plug it into your function to find y. That's how you find your vertex. So basically what we're going to do here is we're first going to find our vertex, and then we'll find a couple more points on our parabola and use our axis of symmetry to get a couple of extras. That way we have enough points to see our U shape and connect them. And this is the process that you'll want to do in ALEX, because I think it's going to need 5 points from you. It'll need the vertex and 2 points on either side of your vertex. So let's start finding our vertex in this problem. There we go. So in this problem, our a value is 1. The number in front of my x squared is 1. And then my b value is the number in front of my x, which is -2. And my c value is this number by itself, which is 4. So that's our a, our b, and our c. So that means that our vertex in this problem is going to be, I won't put it in an ordered pair yet. I'll find each of these separately. The x-coordinate is going to be minus b divided by 2a. So I'm going to have negative b, which is -2, divided by 2 times a, and my a value here is 1. So now if I have a minus, a -2, a negative of a negative makes this a +2 on top. 2 times 1 is 2, and overall 2 divided by 2 is 1. That means my vertex is going to happen at x equals 1. And now to find my y value, I'm going to take x equals 1 and plug it into my function here. So y is going to be 1 squared minus 2 times 1 plus 4. Okay, so that's going to be 1 minus 2 plus 4. 1 minus 2 is -1 plus 4 gives me 3. So that means my vertex is at the ordered pair 1, 3. So 1, 3. I'll put this on here, and I'm going to write a little V here telling me that's my vertex. Okay, so now we know where our vertex is. Now, does the problem that we have here, does this open up or does it open down? Well, that's going to depend on our a value. Our a value is 1. 1 is greater than 0, which means we're in this situation, and this is going to open up. And we're going to be symmetric on either side of my vertex. So what we're going to do now is just get some points. And there's no magic in this. You can pick whatever points you want. I would just pick 2 points, either to the left or to the right of your vertex. So here, let's see. I think I'd rather plug positive numbers in, or maybe we'll just, yeah, so we'll just plug positive numbers in. So I'm going to plug in this one and this one. So I'll just write additional points here. To get some additional points, I'm going to take x equals 2 and plug it into my function to get y. So if x equals 2, that means y is going to be 2 squared minus 2 times 2 plus 4, which is 4 minus 4 plus 4. 4 minus 4 is 0, plus another 4 gives me 4, which means the point 2, 4 is on my graph. When x equals 2, y is 4. That's the ordered pair 2, 4. So I'm going to put that on my graph. 2, 4 is here. And then one more point, I'm going to pick x equals 3, and then I'm going to plug that in to get y. So y is going to be 3 squared minus 2 times 3 plus 4. And then we just need to do the arithmetic here. 3 squared is 9, minus 2 times 3 is 6, plus 4. Now I can add from left to right. 9 minus 6 is 3, plus 4 gives me 7. And that means overall the ordered pair that's on my graph is x equals 3, y equals 7. So now I'll put that one on my graph. 3, 7 is right here. So we can see the side of our U forming. Now, because this is symmetric, I can kind of, I'll put my axis of symmetry in here real quick. That's my axis of symmetry, which means on either side of this, since I have a point here, 1 unit on this side, I'm going to have a point here, 1 unit on that side. Right? If I fold it over that axis of symmetry. If I took this point and folded it over, this is 2 units to the right of my axis, which means I also have a point here, which is 2 units to the left of my axis, right? So you can use that information to, you can use your axis of symmetry to quickly get 2 more points. And now that we have that, I can see my parabola forming, and I can go ahead and connect that with a nice smooth U shape. And there we have our parabola. So you'll start with your vertex, choose 2 points either to the right or to the left of your vertex to get ordered pairs, and then use your axis of symmetry, use symmetry to get those ordered pairs on the other side. Once you have 5 points, you'll put those in Alex and hit the graph a function button and it will fill it in for you. All right, I hope that helps with graphing parabolas. Um, I will see you next time.